Well, I'm looking forward to you hearing me make this bit up right at the very start, because Gordon's just informed me that I'm giving you a very basic précis of what blockchain is. Now, the key to this is normally I have a whiteboard, and normally I'm quite obsessed with pens and whiteboards, so this is looking very attractive right now. Okay, I'll give you a very basic introduction to myself. First of all, you'll notice the jacket's already come off. I arrived here tonight in a waistcoat and a tie. I have had a business for 16 years, and it's the second time I've ever worn a tie. I got in the door, I seen nobody else was wearing one, and it was like a breath of fresh air. It was fantastic. So, I set up QEM Solutions 16 years ago. We are an engineering consultancy, and we've progressed over the past sort of, I would say, 5 or 6 years into software as well. And the reason for that was to create tools that made it easier for our guys to do their jobs better, okay? And to do them more effective and hopefully help the environment they were working in. Blockchain is something that we ended up getting a little bit geeky about and we quite enjoyed, so we continued. So now, this is awkward, standing up and giving you guys a 101 in blockchain when we've got the company that trains people in what blockchain is. Okay, I'm going to refer to blockchain in a way that we see it as from an engineering perspective, okay? Everyone has a different perception of blockchain at the moment, and I think that's because it is used in so many different environments with perceptions of what it could be, or even worse, God forbid, what it has been. You know, and there's a lot of bad press about blockchain because people automatically associate it, first of all, with something really good and then something that went not quite so well. The way we see blockchain is, all blockchain is to us, if we think about it from an engineering perspective, it's a new way of storing information. Okay, if you think of it in its simplest possible form, it gives us a way to start trusting our data again. Okay? Now that can work in various different ways. In its simplest form, so if you imagine blockchain as taking some data and putting it in various different places at the exact same time and taking a timestamp and a note of exactly when that data arrived. Okay? So first of all, let's forget we're storing it in lots of different places. Let's think of it as building a wall. Okay? Bear with me here, this could be a rather tedious analogy, right? So in fact, we're not going to build a wall, we're going to put all these beers in this box here, right? So imagine we've just built this fantastic beer blockchain. Now I've realized halfway through this that the beer right at the bottom of this basin is actually out of date. I don't want you guys to know that because it's kind of embarrassing. They've put a lot of money out in pizza and beers, you know, and to have one that's out of date could be a little bit worrying. So now, if this was a blockchain and I had to go in there and get that beer out, what I would have to do is take every other beer out first, take every ice cube out first, take that beer out, put the one in that was right, and then replace every ice cube and every beer back in the exact same sequence and place that it was before I took that beer out. Okay? Does that kind of make sense? Yeah? Now, Gordon's not rolling about on the floor in laughter at this point in time, which is good because he said he was going to do that if I made a fool of myself explaining blockchain. So if you imagine from a data collection perspective, that's a kind of simple way to think about it. Then from a data replication perspective, imagine we then had 3 baby baskets. It's not a basket, is it? No, it's a bath. I do have 2 children, it shows my input. Imagine taking 3 of these baths, making them absolutely identical, and then I just quickly put another bottle in. Now the key to this would be, is you would know that was no longer correct because it was now different from the other 2 baths. Now that's with what's called 3 nodes. That's one node, your bath's another node, your other bath's another node. The reason why blockchain has become such a strong force in ensuring data integrity is you can have as many nodes as you want. You can have that data stored in as many ways as you want. You can have it encrypted when it's stored there. You can have it non-encrypted. But at the end of the day, if one of those nodes changes, then you know something's happened to the data. One of the things we've worked quite hard on is working out a very basic algorithm as to identify the maximum or the most sort of beneficial number of nodes. And despite the fact you can have hundreds of thousands of nodes, and that's necessary with cryptocurrencies, for just having a blockchain that stores data in a safe and secure manner, You only need 33. You only need 33 nodes. Once you get to 33 nodes, the risk benefit you have from that is negligible because the risk graph does that. Does that kind of make sense as to what?
That was a tour de force.
Does that kind of work for blockchain? Mm-hmm. Yeah? Excellent. See ya. My job is done. No. Okay.
Now for your day job.
Now, do you know what the worst thing is about that? It's that I reeled off, I was fine with that. This, I've actually got a teleprompter on my phone for the next bit, which is the thing. Yeah, anyway. So, the engineering sector and no. Okay, so I'm actually here. So, the idea of this was we were going to talk about how we've kind of applied blockchain to the engineering sector. Okay? We're an engineering company. We're not going to apply it to law. We're not going to apply it to legal. But everything you see here can be applied to any environment. Okay? Now, as I say, I'm from the engineering sector. So I was going to bring a mouse, but I'm moving into the old-fashioned, we're going to push the button. Okay? Not as in push the button, that'd be disastrous. So we've come from the engineering sector. Now, I'm going to tell you a little bit about engineers and blockchain. Now, considering most of our clients still have fax machines, that might be a little bit of a strenuous link. Now, the reality is we didn't have blockchain 20 years ago. Do you know what? We didn't even have it 10 years ago. Actually, we did. It was first invented. Some of you may know this, but it was a New York Times newspaper where somebody actually put an encryption key in a newspaper and then continually repeated that, and that technically became the first blockchain. But we probably didn't need it 10 years ago. It might have helped, but in reality, it wasn't a necessity for what we had. And the reason for this is because we had a greater degree of trust in the data that we held. Okay, we trusted the data. From an engineering perspective, it was relatively easy to see the tip X on the material certificate or the really badly photoed competency record. And a wet signature was genuinely a wet signature. You know, we didn't have high-resolution sort of coloured photocopiers. So why do we need it now? And that tends to be the big question everyone's asking. Why do we actually need it? Is it solving a problem, or is it just somebody offering up something and telling somebody that they need a solution? Okay, from an engineering perspective, there's two primary reasons. Okay? Financial and liability. Those are two really big, scary words in any industry. It doesn't have to be engineering. Financial and liability. From a financial perspective, there's greater pressure on suppliers. There's greater pressure on constructors. There's greater pressure on designers to reduce costs, bring things in time, and that puts pressure on the supply chain. From a liability perspective, the changes made to the CDM regulations in 2015 and the introduction of the corporate manslaughter regulations means that anybody who's involved in a design process or an engineering process or construction process can be held accountable for anything that happens once that asset has been designed, constructed, or operated and maintained. So, for example, if an accident happens because somebody leans over to turn a valve and they fall and it causes an issue, the individual that designed that valve to be on that access platform is liable. And God forbid something terrible happens, then they could go to jail. And this isn't just combined in the engineering sector. This is in every sector you're in, finance and liability. It's the common thread that runs through absolutely every industry at the moment. Greater liability and greater pressures. So, how does blockchain actually help in protecting our liabilities whilst reducing risk, and, do you know what, it can even help us save money. Okay, and at the end of the day, we have to accept the fact that a lot of decisions are very financially driven. Let's have a wee think about liabilities first. Okay, we live in a world where we now need to prove that what we have carried out is legally and contractually compliant beyond a shadow of doubt, and that's before anything bad goes wrong. So we're expected to prove it's correct before anything proves that it's not correct. And the reason for this is because we quite simply no longer trust the information that's provided to us. Now, this could be anything. This could be inspection results. It could be validation that an activity was carried out on time. We need to figure out a way of trusting the information that's provided to us a lot more. And that's a difficult thing to ask. It's a difficult thing to ask in an environment that's very cost-driven and very time-driven. The financial pressures are the exact same to the contractual pressures. Unfortunately, we just tend to have a little less control over them, or I don't know whether that's just the engineering environment. Pressures placed on a client to reduce cost. They place pressure on a contractor. They place pressure on a subcontractor or a supplier to reduce their costs. So that goes all the way down the supply chain, which means we need to rely on the supply chain trying to maintain the same quality all the way through, which is verging on the impossible. The reality is reducing that supply chain, reducing the time and the cost for that supply chain means a cost in reductions in materials or time or competency or lead times. I don't know how many of you have heard the saying, you can have it now, you can have it cheap, or you can have it correct. Choose two. Choose two. What two would you like? It's not possible. Okay, so if you decide that you want it correct and now, it's not going to be cheap. If you want it correct and cheap, it's definitely not going to be now. Now, the problem is the industry, certainly from an engineering and construction environment, is actually pushing us towards they want it now and they want it cheap. So that puts pressure on quality. Right, so this is all very good, and I'm sure I'm not actually teaching anything you don't actually already know, and I just sound like a really cynical Scotsman. But how can blockchain actually help us? How can it help us with these challenges? Well, we've now applied blockchain to some real-life situations. I would like to think it's simpler than we all think. We just need to learn to trust more. If you've seen the thing at the top, did you see what I did there? That took a lot of effort. That took a lot of thought. The entire presentation was built around that one line. We need to trust the integrity of the information, and that's got to be without question. Data needs to be verifiable, and where necessary, it needs to be transparent. And if we think about the complete life cycle of, for example, an engineering project, we need to start recording the data that's collected to verify compliance in a blockchain, okay? So that's our main thing. The things where you need to verify compliance, either for a legal basis or a contractual basis, it needs to be stored in a blockchain so it can be trusted. The difficulty is we can't stop someone maliciously putting the wrong data into a blockchain. Okay, if I intentionally put that beer in there, and it's out of date, and I've put it in there on purpose because I know that Gordon's allergic to out-of-date beer. He tries them all just in case, but we know that if I was to then go back and replace that beer, we can't stop the malicious activity going in there, but what we can do is record when it happened and how it happened. So if we actually try and think some practical applications, and this is obviously based around an engineering environment, okay? But we have recording of design, approvals, appraisals. If you're in an engineering environment, before anything can get built, the engineering design has got to be approved and appraised. Material traceability, supply chain management, inspections, audit results, statutory inspections, written schemes of examination. From an engineering environment, a written scheme of examination is what stops you going to jail. So when the government, when the HSE turns around and says, in order for that asset to remain safe and not blow anyone up and not cause a major incident, you have to carry out this written scheme of examination. You have to do X, Y, and Z. Now, this list is endless. One of the issues we have in the industry at the moment is people don't trust the data. So you may have a written scheme of examination, take incidents that, okay, a horrible example is, you know, some of the major incidents that have happened, let's say in the public domain, where public companies have been involved, okay? Buildings, major catastrophes. If a public body or any organisation has to prove that they didn't contribute to it, for example, because they didn't carry out the right inspections, if they cannot come up with that information immediately, there's doubt placed there. If you have it in an immutable blockchain, there's no doubt because you know it's real at the time. The benefit to all this isn't actually tomorrow's technology anymore. We've been working with a technology partner in Perth, Australia. We've developed a system called TrustMore. Okay, what I want to make everyone realise about this, this isn't meant to sound like a sales pitch. We're quite proud and excited about what we're doing. We're also engineers, so we're a bit rubbish at doing sales pitches. So the whole idea of this was we had a couple of products we initially needed to put data in a blockchain to make it verifiable. In order to do that, we tried to create a way that made it easy to do. So we came up with TrustMore, and TrustMore now gives us the ability to put any data environment, primarily we're focusing on .NET and C#, but any data environment into a company's own blockchain within 3 days with 3 lines of client-facing code. Okay, so depending on the skill set that our clients have, we have some clients that just say, put it in the blockchain, we'll do the rest. And then we have other clients that say, we'll put it in the blockchain and then give us a user interface that allows us to connect our data to that immutable ledger. Now, the idea of it is we've hopefully made it nice and easy. Okay, it's easy and it's accessible. This, I won't go into this, it's on the website, but one of the biggest issues with blockchain at the moment is it's inaccessible and you can't figure out what the prices are. Okay, there are some major offerings out there and a lot of them are based on other technologies that the price fluctuates. Okay, a lot of them are based on, for example, Hyperledger, we have IBM's offering, all these sort of things. They're big systems that are still very convoluted and difficult to understand. The idea of what we tried to do is we wanted to try and make something that was easy to implement and for the client to understand. So, what have we done? So we've taken some of our clients and we have actually put them in the blockchain. Okay, so this is where we have actually applied this. A good one we're quite excited about is an organisation called EZID. Now, EZID are based in Perth, Australia, which doesn't give me enough opportunity to get out there, but it would be lovely if it did. And EZID are an asset tagging company that work with lifting companies and lifting tackle. Now, they have placed NFC tags on all of their lifting equipment, and now an individual can scan that NFC tag, and the minute they scan that NFC tag, they can see where the lifting tackle was made. They can see the documentation associated with that lifting tackle. They can see when that lifting tackle was last inspected. They can see if it's had any issues. And they can see if it's transferred ownership, so it builds in the supply chain. Now, the benefit of this is they're no longer scrabbling about hunting for certificates, looking in spreadsheets. It works with their phones. RFID tags, so long as their phone can read NFC, they have the information at their fingertips. Mineral Blue is quite an exciting one for us. I've spoke to a couple of people in the room earlier about Mineral Blue. Mineral Blue is a safe system of work. Now, Mineral Blue does various things. It validates competency records, it validates that isolations and permits were in place for organisations. But the key to it is the information that is required to prove that something was done correctly is stored in the blockchain. So if something, God forbid, did go wrong, it's easy enough for somebody to turn around and prove that they had done the right thing at the right time. Okay, now is compliant. I have a bit of a. This was actually our own product, so we actually created is compliant ourselves, and this is where TrustMore came from. It was a way of us putting the data from is compliant into the cloud. Now, the reason for this was we needed to be able to prove from a client's compliance perspective that all the inspections, all of the information in there was real and it hadn't just been kind of fudged into there the day before the audit. Okay, so that was the idea behind this compliant. Now, finally, this is an interesting one. This is Matter. Now, Matter is they collect waste, okay? But they collect waste and they want to save the planet. So what Matter does, Matter is an intelligent way of collecting waste. These guys are also based in Australia. Now, it collects waste based on sensors within the bins. It acknowledges what is in those bins, whether it's for recycling or whether it's going to landfill, and it starts to build up a true-to-life picture of what is happening from a carbon perspective. Now, what we've done with this is instead of just having this in, collecting waste information, we're actually building it into a thing called a carbon file ledger. Now, the idea of the carbon file ledger is we want it to become almost a global carbon ledger that can be trusted because you can validate the information that's in it. So basically, anything that's classed as sinks or emissions, okay? When you do something really good for the environment and reduce carbon, it goes in to give us the thumbs up that we're doing the right thing. If we do something bad, we're not actually reducing our emissions, we're increasing our emissions, it goes in so it shows that we're not doing something well. And that way, it's the only way we'll build up a proper view of whether or not we are reducing our global carbon footprint. Now, one of the issues with blockchain, obviously, is it's always been associated with cryptocurrency. We need to take our mind away from that. The idea behind blockchain now, think of it as a separate entity. Blockchain was just something that cryptocurrencies could facilitate themselves on and engineer themselves on. The benefit of blockchain now is it is basically a ledger that stops us from needing to just assume that something's correct, and it now proves that it's correct mathematically. So, if we're going to move forward with blockchain, if we're going to move forward with actually beginning to believe the data we're holding and knowing that someone hasn't scribbled it out with Tipp-Ex or colour photocopied it, now's the time that we've got to start to trust more. And that's it. Start.